Automate LLM output evaluation in Python fast. By the end, you will have a compact evaluator that reports exact match accuracy, a character Jaccard similarity score, a best answer selector, a brevity adjusted score, and a pass at 2 result across 2 tries. You will know how each measure works, where it helps, and how to tune one parameter to trade precision for recall. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced in simple Python. Why this matters. Automated evaluation turns subjective inspection into repeatable numbers. The core property we optimize is accuracy, which tells us how often a model hits the expected output. A key trade-off is strict exact match versus fuzzy similarity. Exact match is cheap and precise, but misses paraphrases. Fuzzy measures cost a little more and capture variety. Practically, these simple checks let you evaluate hundreds of responses in seconds on a single laptop. Concept overview. Think of this as a suite of small checks that together approximate human judgment. Exact match catches verbatim correctness. Character Jaccard catches overlap when word order or small edits change surface text. Selecting the best candidate picks the most similar output when a model returns many attempts. A brevity penalty nudges scores toward concise answers when that matters. The main limitation is semantic understanding. These methods miss deep paraphrase and factual nuance. We'll build a pipeline that reads references and model outputs and prints a compact report with exact match accuracy, character Jaccard, a best answer chooser, a brevity adjusted score, and pass it 2 across 2 attempts. Now we move to the first evaluator component. This snippet computes exact match accuracy after simple text normalization. It shows a normalization step that lowercase text, trims extra spaces, and removes simple punctuation before comparing strings for equality. The snippet counts how many normalized model outputs equal the normalized references and divides by the total to produce accuracy. That accuracy number is the count of exact matches over examples. If the snippet exposes a normalization level parameter, relaxing it by allowing punctuation or case differences will raise match rates but can hide real errors. Tightening normalization yields fewer false positives but lower measured recall. Next, we add the second evaluator component. This snippet measures order-insensitive similarity using character Jaccard. Jaccard is defined as the intersection size over union size of 2 sets. And here, the sets are character shingles or single characters from each string. The output is a number between 0 and 1 that reflects how much the model output and reference share characters. The snippet optionally accepts a shingle size parameter. Increasing the shingle size makes the similarity stricter and more sensitive to exact sequences, while smaller shingles make it more permissive and tolerant of rearranged characters. Larger shingles usually slow computation slightly, but reduce false positives from tiny overlaps. Next, we add the third evaluator component. This snippet selects the highest similarity answer for each reference. When a model returns multiple candidate outputs per prompt, the snippet computes a similarity score for each candidate against the reference and picks the candidate with the maximum score. It handles ties by choosing the first highest score or by applying a deterministic tie break. If the snippet exposes a top K parameter instead of top 1, raising K lets you report a top K accuracy or aggregate score and increases pass rates at the cost of looser evaluation. Selecting the best candidate mimics an oracle chooser and helps measure the model's best case generation quality. Next, we add the fourth evaluator component. This snippet adds a brevity penalty to prefer concise, correct answers. It computes a brevity multiplier based on output length relative to the reference length and applies that multiplier to the similarity or match score, so that overly long, rambling correct answers get a modest penalty. The snippet usually exposes a weight parameter that controls how strongly brevity affects the final score. Increasing the penalty weight biases the evaluator towards shorter answers and may boost scores when concision is desired. but set it too high and you under-reward necessary detail. This is useful when brevity is a genuine product requirement. Next, we add the fifth evaluator component. This snippet computes pass at 2, counting if any of 2 tries matches. Pass at 2 is defined as the fraction of prompts for which at least one of 2 sampled model outputs meets the success criterion, usually exact match or above a similarity threshold. The snippet implements this by grouping 2 attempts per prompt, checking each attempt for match, and marking the prompt as passed if any attempt matches. If you change the number 2 to a larger K, pass rates increase predictably, but variance across runs falls only with more samples. Pass metrics reveal how often a model gets lucky within a small number of attempts. Recap. This typeline combines exact match, character Jaccard, best answer selection, brevity adjustment, and pass at 2 into a fast, interpretable evaluator. Use it when you need repeatable, quick checks over many outputs and when semantic depth is not required. One caveat: these measures are surface-based and miss deep paraphrase and factual correctness. Wrap punch. One practical next step is to tune the character Jaccard shingle size and measure the trade-off between measured accuracy and evaluation speed on a larger data set. If you like short, practical AI engineering guides, subscribe and watch the rest of the AI engineering videos.